Okay, so body of mass 8 kilograms falls from rest under gravity. Okay, it experiences a resistance force of 0.1 v squared, where v is the speed of the body. Find the time taken to reach a speed of 21 meters per second. Now, think about it, it's falling, yeah? So the direction of acceleration is downwards, okay? That's the direction it's going in, direction of motion there. So it's got a resistance of 0.1 v squared, okay? The air resistance, yeah, as it's falling, okay? Now, in terms of the force making it fall, because there is a force making it fall, isn't it? And it says that under gravity, okay? So it has got like a driving force to it, okay? Due to the effects of gravity. All right, you've got to remember that it is something pulling it down, yeah? And to work out the effect of that force, remember, it's just the mass times the acceleration, yeah? So the mass is 8 times the acceleration, which of course is going to be g due to gravity. Okay, so that will be the driving force of this body. So when I apply then Newton's second law in the direction of increasing motion, the resultant force is mass times acceleration, yeah? So the resultant force is going to be, well, we've got 8g, which is the driving force of it. Take away then the resistance force, which is 0.1 v squared, and that will equal to mass times acceleration, 8 times a, yeah? So the resultant force is mass times acceleration. Now remember we discussed before, it is better to try and change that to 1 if possible, so I need to times through by 10 in that case there. So I get 80g, take away v squared, times that by 10, times this by 10, times this by 10, and times that by 10, I get 80a. Okay. The other thing then, of course, I know g to be 9.8. And when I work that out, 80 times 9.8 is 784. Okay. So then I'm going to apply my expression for acceleration, which is dvdt. And I get that there. So I'm going to solve now my differential equation by separating the variables. So I'm going to keep the 80 where it is, take that over there though with the v's, and then take the dt up. So I've got the integral of dt equals to, well, let's put the 80 outside the integral. And then when I got 1 over this then, 784 take away v squared dv. So when I integrate it, dt then is 1 dt, so integrate I just get t, 80. Now here, again, standard results in the formula booklet, okay? It's just going to be the same one as last time, actually, right? It's going to be that one there. Because I've got a squared take away x squared, is what I've got here. A squared take away, and there's my x squared there, so they just use the v instead, don't they? A squared is 784, so to work out what a is, just got to think what am I squaring to get 784, so I just got to square root 784. If you do that, you get 28, it comes up quite nice. So applying that then to this formula, 1 over, it'll be 2a, so 2 times 28, ln 28 plus v, and the bottom then 28 minus v, plus then your constant. Okay, so work all that out on your calculator and it comes to 10 over 7, that simplifies to b, okay, and then you've got ln of your 28 plus v, 28 minus v plus c. Okay, so then given v is 0 and t is 0, So you chuck it in. 0 is 10 over 7 ln. So put 0 in here. Okay. And that just comes out to be 1, doesn't it? So 28 plus 0 over 28 minus 0 plus c. So that just comes out to be 1 in that ln there. So ln1 is 0, so that means c is 0. Okay. So you've got t is equal to then 10 over 7 ln 28 plus v over 28 minus v, and c is 0. And the question asks, isn't it, find the time taken for it to reach a speed of 21. So you could say, look, when v is 21, t is equal to 10 over 7 ln 28 plus 21 over 28 minus 21. So if you work that out, on the top you get 49, on the bottom you get 7, and 49 divided by 7 is 7. So you get 10 over 7 ln 7, and that comes out to be 2.78 seconds.